It's possible you can solve this by drawing it to scale and then using your ruler among other tools to solve this problem in full. But as you can see, you've been told that method has been rejected. So to solve this using the other method or the analytical method, this is what you do. So let's just go through the question. In the diagram, the position vectors or the points Q and P are 6i plus 6j and 5i plus j respectively. The point x lies on QP, such that qx to xp is 2 to 3. So now find ox. So to find ox, you can just mess around with this ratio and make ox the subject to the formula. Yes, it's possible you can start with maybe oq plus qx and then you find qx, but I think that's a lot of work. So let's just use this. So qx to xp is equal to 2 to 3. So now to solve for ox, you can cross multiply first. These are vectors, by the way. So this would be 3qx is equal to 2xp. And then you can break this one down into position vectors. So this one will be 3qo plus ox, and then you close. Then this side you have the same thing, ox plus op, and then you close. And then you can just change your xo since you want ox, so you can change this one to ox. Let's just expand this one, qo. You can even change this one if you want, plus 3ox is equal to, when you change this to ox, it becomes a negative, and then when you expand, you have negative ox. Remember, for vectors, xo is not the same as ox. So xo is equal to negative ox. And then this times this, you have 2op, like this. And then we can just take the ox this side, everything else to the other side. So you have 3ox plus 2ox is equal to 2op. You take the 3qo to the other side, you have minus 3qo, like this. Then these two are like terms, so you have the 5ox is equal to, you know what your op is. OP is 5i plus j, so you can just put your 5i plus j here, minus, you know what your QO is. OQ is positive 6j, and then your QO should be the negative version of this. So this one will be 3, you put a negative sign there, so you have negative 6i, negative 6j. And then we can simplify this further by saying this times this, you have 10i, this times this, we have 2j, and then we have positive 18i and positive 18j. Then 5ox will be, you add these two together, you have 28i, you add this to this, you have a 20, and then you can divide both sides by 5, so that your ox will be, you can just leave this like this, usually as a mixed fraction or a decimal fraction, but for now I'll just leave it like this. And then 5 into 20, that's a 4. Then you have this and you're done. So this is your ox. And then find angle OQP. So to find angle OQP, this is where angle OQP is. So if you want to find this angle, then the two vectors forming that angle should both start from Q. You're not going to use OQ and QP. Instead, you use QO and QP. Once you use OQ and QP, you are basically finding the angle which, so if you say OQ and QP, you are basically just finding, it's actually complicated, but you are finding the angle here. So to find this angle here, make sure that your angles are both starting at Q. So yeah, I mean your vectors are both starting at Q. Let me just flip this page. So now I can use this and this. So I can use QO and QP like that. So let's just find our QO, which is easy. So QO is basically just the opposite direction of OQ. So this one will be minus 6i minus 6j. And then your QP is basically just QO plus OP. So QP will therefore be QO, which is negative 6i negative 6j, plus OP, which is 5i plus j. And then you can simplify this so that you have this and this, that's minus I, this and this, that's minus 5j. And then now you can find your angle. So to find your angle, you can use the fact that the dot product between vector A and B is given by the magnitude of A by the magnitude of B multiplied by cos theta, where theta is the angle between A and B. So now we can take this as our A. It doesn't really matter which one you take as your A. And then our B will be minus I minus 5j. And then the magnitude of your A, let's say this is our A. So the magnitude of this will be the square root of the square of this plus the square of that. And then multiplied by the magnitude of B, which is the square of 1 plus the square of minus 5 multiplied by cos theta, like this. And then you can expand now. Of course, to multiply vectors, you just multiply the i's and the i's, the j and the j's. Because once you multiply the I by the j, you'll get a 0 because these two are perpendicular to each other. And the dot product of two perpendicular vectors is always 0 because the angle between them is 90 degrees, and cos 90 is 0. So this multiplied by this, you have positive 6. This multiplied by this, you have positive 30. And then the square of this is 36. The square of this is 36. Together you have the square root of 72. The square of this is 1. The square of this is a 9. No, a 25. This is a 5. So when you square your 5, you have a 25. And then 25 plus 1, you have a 26. And then cos theta, like this. And then now you can multiply these two and add these. So this plus this, you have 36. And then when you multiply these two, let me just use my phone because I do not have my calculator with me right now. So using my phone, 72 by 26, we have 1872 cos theta. Then you can just divide both sides by the square root of this. so that your cos theta is 36 divided by the square root of that. So you can say 36 divided by the square root of 1872. So this is approximately 0.8321, correct, to 4 decimal places. And then your theta would therefore be the arc cosine or the cos inverse of this. So let's see. So this is that, and then we can say inverse cos 0.8321. Okay, so in degrees, this is 33.6. That's 33.6849. And then rounding it off, correct, to 1 decimal place. Remember, for angles in degrees, you always round them off, round the final answer off, correct, to 1 decimal place, and you're done.